Yes, Shahid, am I audible to you?
Yes, ma'am, you're audible.
Yes,
Yes, ma'am, you're
Shahid,
audible.
your voice is, yes, now it's coming. Okay, Shahid. See, as I had told, we'll start with ray optics. I don't know, Fadil hasn't joined yet. Because of him, especially, I wanted to start this lesson. Anyways, as we have decided, we'll proceed with ray optics then. Now, ray optics, we have already started with ray optics, and we know that the branch of physics that deal with deals with the behavior of light is known as ray optics, in which you have three phenomena occurring: reflection, refraction, and absorption. So absorption, as I told you, that's already a part of your class 11th in your thermal physics unit. Reflection, refraction will be studying over here. We have started already. Now, in reflection, just two things were left that weren't discussed in your batch. When we are talking about reflection, there are two types of reflection which occur. One is known as regular, or you even call it as specular. Regular or specular reflection. Other one is diffused reflection. So regular reflection basically means, specular reflection means light rays are coming on a smooth surface. Normal reaction has been formed. This is going. Again, light rays are coming on smooth surface. Normal is there. They are getting reflected like this. In diffuse, the surfaces are irregular. So suppose here an incident ray occurs. So this surface is like this. So the normal will also be like this and reflected ray will be like this. Correct? And suppose this is the surface. So normal to this will be this, reflected will be like this. So you see all the rays that are getting reflected are having different directions. So this is the difference between regular and diffused. Terms you should know. That's it. Just the terms you should know. Coming to laws of reflection, which we have already studied. Two laws of reflection are there. What are the laws of reflection? Angle of incidence is equal to angle of reflection. And second one, that all these three, angle of incidence, reflected ray, incident ray, and the normal all lie in the same plane. We'll not be discussing it in detail because that we have already discussed it. Fine. Now, one thing, plane mirrors were deleted from your syllabus, these number of images, but this is a part of your JEE syllabus. So this has to be dealt. When, let me start with reflection from plane mirror. All right. Look, see reflection from plane mirror. These are the two surfaces of plane mirror. So this side has been polished. This is the available area for reflection. This side also has been polished. Now there is some angle that is formed, and we also talk about a bisector wherever where object can also be kept. This is known as bisector. Here the object can be kept. Now the number of images that are found. All right. When you have inclination, you have to find out the number of images. So see, not one formula is sufficient. You have different formula. First is, see, if they are inclined by some angle, let's say theta, And the number of images that are formed, let's take this as n. Number of images that are formed. Number of images. And theta is the angle between mirrors. All right. So if you take 360 divided by theta, you're getting. Fine. If you're getting 360 divided by theta, let's say this is some m. This is some m. Whatever value is coming, this is some m. So number of images n will be whatever you're getting, subtract 1 from it. M minus 1. When will you do this? If the m that you have got, the m which you have calculated, this is coming even. Suppose 360 divided by some number, I am getting, let's say 2. So 2 is an even number. Two mirrors are there. One image only forms. So number of images 2 minus 1, 1. Second case. If 360 divided by theta is coming m and m is odd. Now, if it is odd, no, there are also two cases. The two cases that are followed, bisector, I told you, the line that is bisecting the angle. So two cases where the object is kept at bisector and where the object is not kept at bisector. So object not kept at bisector, object kept at bisector. So if it is not kept up, kept at the bisector, simply number of images will be the number of value when you're getting 360 divided by theta as it is. This will be as it is. But if it is kept on the bisector, then again the same value, n is equal to m minus 1, because this is exactly at the center. So with odd, you have to be careful. And see, sometimes it's not necessary that you will always get it as a proper whole number. It can also happen that this 360 divided by theta, you're getting m, and here m is in decimals, like fraction. It can happen you're getting 3 by 4, you're getting 5 by 2. You do not know which values are there, right? So what you do, just nearest even integer take it. Your n becomes nearest number of images. This is the nearest even integer. Nearest even integer in case of the symmetrical images whenever it is formed. Fine. Take any example, put in the value, you will get the values. If theta is 0, if suppose you're getting the value of theta as 0, example, you're getting theta as 0. So m will be 360 divided by 0. 1 by 0 is equal to infinity. So if the angle between the mirrors, this is 0 degree. So whether it's symmetrical mirror, asymmetrical, whatever it is, number of images, this is equal to infinity. Fine, this is equal to infinity. All right, let's take an example. Let's take one more example, because this also we haven't discussed. Let's say theta that is given to you is 30 degree. Fine. So m is 360 divided by theta, which is 30. This is equal to 12. Correct? This is equal to 12. So 12 is even. For even number of images is m minus 1, which is 12 minus 1. So number of images is 11. Clear? Now I'll give you some values of theta. You will tell me the answer. First, write it down till here. Write it down till here. Then I'll give you some values of theta. Number of images you will tell. These values quickly. Answer. First part, second part, third part. Yes, class, see if theta is 45 degrees. So your M will be 360 by 45, which is equal to 8. So here this is coming even. So number of images will be 8 minus 1, which is 7. So 7 images if theta is 45 degrees. Suppose you're getting 75. So M will be 360 degree divided by 75. So this will be 4.8. Now 4.8 is in fraction. Fine, 4.8, this is coming in fraction. The nearest integer you will take. If this is 4.8, nearest integer will be 4 simply. So number of nearest lowest integer you take. Nearest even integer you take. So if you round it off to a greater one, that will become 5. So lesser one rounded off would be 4. So this is 4. This is 360 divided by 112.5. So this is around 3.2. So here also the number of images will be 4. Because if you take the lower one, that will be 3, which will be odd. So we take the even. These are the answers. 7, 4 and 4. Write it down. Yes, class. So see, this says that a thin rod of length f by 3. So the length of this rod is f by 3, this part. Fine. This is placed along the principal axis of a concave mirror of focal length f such that this image, which is real and elongated, just touches the rod. What is its magnification? C class. One edge is this f by 3. One edge is this f by 3. This is formed real and elongated, and if it is saying that it just touches the rod, it means image must be somewhere here, right? Image must be somewhere here. So see, if this is coinciding, object must be between the center of curvature and the focus. This must be the center of curvature. And if this is the center of curvature, this becomes twice the focus. That's what we have studied. We have done this derivation also. Correct, class? Yes, what are your answers coming? What answers have you got for this question? Magnification that you're getting. Anyways, this part, if this is f by 3, this is 2f. So this part that is left, this will be 5f by 3. Correct? This will be 5f by 3. Length of the rod is f by 3 and distance also we have taken it as 5 by 3f. Now we have to find out the distance of image from this end and from this end. We have to find out image distance, or if you do not want to write this, you can find out from this one edge and the other edge. Right, from one end to the other. If we take this as the object distance, this total 2f as the object distance, then what will be the image distance? And if this is taken as object distance, what will be the image distance? This you have to find out. Now tell me what should be the value of this. This is UA, object distance. What will be the object distance which you will be considering? Object distance that you have to consider, this is 2f. Correct, this entire is 2f, so put minus sign. And the object distance that you have to consider for B part, this is 5 by 3f, again minus sign. So, and you know the focus of this is f. The focal or length is already f, which will also be taken as minus f. Now find out VA and VB. Now at least you will be able to do. Try it. Now tell me what is the value of VA coming, value of VB coming. Simple mirror formula you have to apply.